Tēnā koutou and welcome to this SESOC Emerging Structural Engineers webinar, where we will be formally introducing the BOKS and taking a closer look at what the CPEng process looks like for a structural engineer. As Bernie said, my name's Laura and I'm Chair of the ESE and facilitator for today's webinar. To give everyone a bit of an outline of what we'll be looking at today, first up, Stewart Hobbs will introduce the BOKS, or Body of Knowledge and Skills, and how they are used in the CPEng process. John Heenan will share his perspective as a practice area assessor and what he looks for in the application and interview. Amber Coulthard will share some tips and tricks based on her recent experience going through the application process. And finally, SESOC President Michelle Grant and CPEng board member Paul Campbell will be giving us an insight into the future of CPEng and what SESOC is supporting with changes to occupational regulation. As Bernie mentioned just before, if you've got any questions, just log them in the Q&A box and we'll come to those at the end. So first of all, I'll hand over to Stewart Hobbs to introduce the BOKS. Stewart is a director at ProConsult Limited, a fellow of Engineering New Zealand, and has served on the SESOC Management Committee on and off for over 20 years. He is passionate about structural engineering and has taken a keen interest in the development of the profession, with input into the compilation of the SESOC BOKS, and for the last 5 years, chairing the Competency Assessment Board. Thanks, Stewart.
Thanks, Laura, and welcome everybody to this session. So my role has been as chair of the Competence Assessment Board. I've seen a number of things going through in terms of where we used to be and where we're heading with the quality of engineers going through the process of acquiring a chartership. The BOKS were prepared, I'm guessing it was about 5 years ago now. Paul might be able to clarify that down the track, but they have been there, sitting there for a while. And the BOKS, or bodies of knowledge, were created by SESOC because they foresaw the potential for problems with the practice out in the, as perceived by the public. And we believed that we needed to tighten up on the quality of the engineer coming through for chartership. So the BOKS came about because CSOC was worried about the standard of structural engineers in the community, and we needed a reference point for moderation for the chartered professional engineers. What happens now is the assessors assess candidates, and they use guidelines and that have been provided by Engineering New Zealand. They aren't the BOKS, but many of the underpinning criteria are some of the BOKS, or that there is a crossover. But it needs to be refined and standardized because it will give us much better moderation. So we need a reference point. The intention is that it's used by the assessors, not as much now, but many have taken it on board, but we need to formalize the process. I don't see it as being, as what somebody mentioned to me the other day, as being elitism. The idea of the BOKS is to provide a base level that we can work to, and the Geotechnical Society and Fire Engineering are also putting together BOKS. And eventually I see this rolling out right through all disciplines, and Paul will enlighten us on that later. CSOC's put a lot of work into it, and ours have been completed for some time. The Geotech's getting there, and the Fire have got a little bit further to go, but it won't be long before they're catching up with us. The CPEng board, the newly formed one that is represented by Paul today, is likely going to change the process that we have in place now. And I'd say the BOKS that CSOC have created will be sitting pretty high on the list in terms of how they're implemented. There'll be a lot more work around CPD, and we want to make sure that the bar, using a qualitative process, can be measured. That's what we're trying to do. That said, we still do use quantitative measures, some of the assessors. If we have a problem in an interview with a candidate at the interactive, we will provide a written question to just flesh out what we think they know and don't know, where there are doubts about their competence. So the box really underpin competence, complexity, knowledge, and skills. And Larry Bellamy was good enough and drove this really. He put a lot of work into it. So at the interactive, I need to make it quite clear that the work you present for your CPEng has to be the work you've done. It's no good taking on a complex project and getting a lot of guidance from senior engineers or principals of the company and saying it's your own work. If you haven't done the work and you don't understand it, the assessors will find out. So it's really important that it's your own work that you're putting up. And I think also when you're putting your work forward to the Engineering New Zealand, when you're submitting it for the registrar, you need to not be modest. You need to say, this is what I've done. This is how I did it. This is how it demonstrates what I'm trying to show you. This is why it's complex. So it's I. So modesty goes out the door. We want to know what you've done and how good you were at doing it. I think the other thing is that the submissions to Engineering New Zealand are pretty ratty at times. It's really important that one, your English is good. Two, that it's logical and methodical the way it's presented. And three, that you're actually saying you're answering the questions that Engineering New Zealand are looking for. And there's no need for waffle. So I think the next question is, how will the box be applied? I think it will be in a very similar manner that they're applied now through the assessments. I think that there's limited application now, but it's getting better. But many of the assessors now use the box for putting out questions to clarify issues. And when we go through the box and see the last part of the box in the 7 categories that the box are framed around, you'll see what I mean. Because it's no good if you are working in a very narrow and deep field, such as designing studs in a factory for a house construction, steel studs, you will not get chartered. You need to have a reasonably broad experience and be able to demonstrate that to show that you're a capable engineer. So if you're in a very narrow field, you need to somehow prove that you can understand other complexities such as capacity design and so on. So we've talked about this already. The engineering competence standard comprises 4 group elements: knowledge, acumen, management, and technical competence. And we've tried to bring this all through in the box. And I'm just going to skip through this and go straight down to what it actually comprises. So the project phase, you need to demonstrate that you can understand the problem, how the problem's formed, and how to go about a solution for it. And that's what this part of the first of the 7 box comprises: project brief and initial investigation. You need to be able to perform technical literature searches or demonstrate that you can gather relevant information to undertake the project, including developing briefs for obtaining missing information. Now, what I'm going to say here, I'm just going to break out and just say that this is a generic document that we have put together and said underpins what all professional engineers, I'm going to use the word professional, should be able to do after 5 years of experience. So it's generic in some ways and it's quite pointed in other ways, and you'll see what I mean as I go through it. And at the end, I'm going to actually relate that back to what you need to do when you submit for submit your documentation. You need to understand the design process and processes and coordination, understand peer review and building consent procedures, and the level of information required for building consent. You need to understand the general principles and terminology associated with structural engineering as they relate to building structures or civil structures. This is as much about communication, but also about how you interact with other designers. So for instance, designing a beam in a building is all very well, But if the services can't pass through it because there's not enough room for the services to get through, well, then you're going to have an issue. So the coordination side of it is exceedingly important. And understand how each of these influence the design of a structure. The second of the 7 is the concept and preliminary design options and alternatives, and identification and evaluation. So you need to identify the physical conditions of a building code that it requires for the proposed structure, identify physical conditions that are outside the scope of the loading codes and standards, and identify and evaluate potential solutions. You also need to be able to identify the appropriateness of proposed materials, calculate design actions and combinations of design actions using standards, identify load paths through through structural systems, a very important one that should be tagged out. We were talking about that the other day because we still get people applying for CPEng and their load paths haven't been correctly identified. Use indeterminate analysis methods to redistribute internal design actions. Use hand methods to estimate design actions for structural elements. That's cross-checking computer printouts. We do not like computer printouts submitted en masse for your assessments. It gives us no assistance whatsoever in determining what you understand and don't understand. So those on their own or without explanation are no help to us at all. Perform and interpret the results of computer analyses, identify the limitations of structural analysis methods, understand soil structure interactions, evaluate and recommend structural systems for gravity and lateral design actions. Identify collapse mechanisms and global stability. Select components or dimensions of structural elements required to resist the design actions for each element. Identify potential effects on the structure and the surrounding environment. Collaborate with other project stakeholders. Communicate design issues, very important, and that you will be sought out in your interactive. Document and development of a design and write a design features, a report that communicates the structural systems in the structure. It's quite a detailed account, and that was done on purpose, but you'll see that it makes sense. So I'm going to go on to item 3, the developed and detailed design and construction documentation. I'm not going to hang on these. I'm going to go through them really quickly because these can be made available to you through Engineering New Zealand after the presentation. Understand the manufacture principle of engineering properties and durability, cost, availability and potential applications of the 3 key construction materials: steel, concrete, timber. So if you're going to go for an application for a CPEng and you're going to just demonstrate your capability in one material, that's going to give you a very narrow, limited field of understanding. So you need to also demonstrate how you've made up for that in other areas. Very important. Prepare engineering and quality specifications, commission laboratory tests, understand quality control processes, accommodate the effects of creep, shrinkage, thermal effects, and so on. Calculate design actions for structural elements within a structural system, including foundations. Check local stability, check the local stability of the element components, identify the response of the structure, determine ductility, capacity and demands, design elements to avoid undesirable or unacceptable deflections or vibrations, design connections for 2 or more types of materials, detail penetrations with significant changes to the cross-section, detail other types of connections, seismic accelerations, and so on. I'm not going to dwell on that anymore because I think we all understand what we're trying to achieve. 4 is the construction monitoring of projects. So if you're going to put down on your PAD, design and monitoring of low-rise buildings, you need to provide evidence that you've done monitoring. You need to either present something with your name on it that shows you have done site inspections and possibly what the consequences of those site inspections were. So it's not just about design, it's about everything that you want in your PAD has to be underpinned by evidence. Monitor and review construction processes, understand construction contracts. I'm just going to roll this down slowly. You can probably all see what I'm rolling down. Propping, that will be particularly important for a new field that we've just created called the construction engineer. And they would have to have an understanding of propping and demonstrate that with calculations. Be familiar with health and safety requirements. That's near the end also, but not just in general. It's your obligation when you go onto a site as well, and your obligation with regard to health and safety and design. Engineering New Zealand have got a very good paper on that. Know when to commission laboratory tests, understand and implement quality control processes, accommodate and mitigate where required the shrinkage, creep effects, and prepare maintenance schedules. The next one is the structural performance assessment. And that's identifying critical structural weaknesses. We do that if we're doing building assessments. You need to know what a CSW is, and you've got to be able to demonstrate how you got there, demonstrate an understanding of the principles and process for assessment of existing buildings, and design retrofit systems. Now, some people might do this sort of work, and I'll come back to that and explain where we sit with that. Awareness and use of key technical, awareness and use of key technical documentation, guidance and standards. So you need to understand the codes. And most people who use them regularly have a fairly good memory of what's there and what isn't, and how they get applied, or where you need to go and find the information. And these are what SESOC believes you should be familiar with in terms of knowing about them. I will say you don't need to know where the clauses sit in every book, but you need to know that they're there and what they do and how they're applied in general. Those are all guidance notes and references that a good engineer would use at all times in their practice. Understanding of the building and health and safety regulations, and there we've talked about the Building Act, the regulations, and demonstrate a good understanding of the Safety at Work Act and Chartered Professional Engineers of New Zealand Act. You're asked about that at the interactive. Everybody's asked about safety and design at interactive. I've probably given you a nice big hint there, but that's what happens. And you're also asked about your projects that you've submitted so that we can get an understanding of what you understand, and that gives us help to determine whether or not you cross the bar or not. Now, in putting this together, some will apply to what you do and some won't apply to what you do. But what we're saying is that, generally speaking, a structural engineer with 5 years experience should be able to undertake at least 2 of these types of structures. And a regular 2-story building with bracing elements, beams, lintels, supports that require specific design, a pedestrian bridge over 2-lane road, a 3-metre high retaining wall, and a light industrial building. Now, we came up with those as being reflective of something that would be base knowledge that any competent chartered professional engineer should be able to undertake and design, at least 2 of those. This hasn't actually gone through at this stage as a written exam or anything like that, and there's not necessarily any intention to do that. That's something that the CPEng board will be looking at, but how this is applied overall is going to be interesting. The other thing that I struggle with is that you've got a number of factors that won't affect some engineers, but some factors will be, such as load paths, will be critical for everybody. So can you get 80% like you do in an exam when you've gone through university? And you do get 80%, will the building fall over? If it was load paths, you'd probably have to get 100%. But in fact, you would. If it was something else, maybe 80% is appropriate. We're not sure how it's weighted yet, and maybe Paul can enlighten us on that when he has a chance to speak. So we said that 2 of those would be very useful for a structural engineer to have a understanding of as a minimum, to demonstrate their competence and understanding of complex work and knowledge. We also said that preparing or supervising the preparation of structural drawings for at least 2 of the types of structures listed in A would be useful as well to demonstrate your competence, and carrying out construction monitoring of any types of structure listed in A above. And there might be other types of structures you've been involved with that are complex that would meet the criteria. And carrying out a structural assessment of a 2-story building. I think it's important that you can demonstrate that you know how to assess existing structures as part of your CPEng. I think that's pretty well it from me. I just have one more note I'd like to add. And that's, I've lost my piece of paper, here it is. And that's that if you're working in a narrow and deep structural environment, it's really important that you try and get experience either through a mentor or through another organisation to stretch out that experience. You probably need to know how to answer a question on ductility. Like, this is how much I know, but because I design houses in Auckland, I don't know much more about that, but here's what I do in this situation. So you need to understand what the framework of that is. And I think when you go and do a CPEng, you're not going to try and assessment when you're going to go to the interactive. Your job is not to answer every question. It's to really demonstrate that you understand what your boundaries are and the limits of your competence. That's what the assessors are trying to understand. I think I'll hand back on to the next person. Thanks, Laura.
Thanks, Stewart. That was a great introduction to the box. For anyone who hasn't seen that document before, it sits on the SESOC website under their library, and we'll send a link through to everyone here as well so that you can have a bit of a more detailed look through it in your own time. Next, I will hand over to John Heenan, who is a technical director at BEKA and has acted as a CPEng structural practice area assessor for about 11 years. He is going to share his opinion on what makes a good application and what exactly the practice area assessor is looking for in the application and interview process.
Thank you, Laura. Welcome everyone, and thanks for calling in or joining in. As Laura said, I've been a practice area assessor for 10 or 11 years and have undertaken quite a number of assessments in that time. So we'll just look at this 3 parts to your application for CPEng. Obviously, the first and in my opinion the most important part is the evidence submission. The advice that I give candidates that are submitting for CPEng is to treat your application a little bit like you would any other engineering project. You need to identify the problem, which is obviously the submission, gather information, determine what's required to answer the questions, put it all together, get it verified, have a mentor preferably, and then submit it. We do see quite a range of different quality submissions, but the best ones are the ones that have actually gone through what you would sort of consider a bit of a the rigors of what you would normally expect in an engineering project. Then the interactive interview, hopefully we don't fall asleep during that one, and depending on the outcomes of the interview and this evidence submission, there could be an additional assignment or question or submitting additional evidence. So I've broken this up into the various evidence groups. So the first group being engineering knowledge, where you're going to submit preferably 4 to 5 work examples. And those work examples would normally include calculations, drawings, design feature reports, any other documentation that may be pertinent to that project. Based on the submitted evidence, I was reading just recently that the burden of proof is not with your assessors to try and drag your competence out. It is up to you to demonstrate that you are competent to practice. So that's the, as Stewart referred to, that's the I in this thing. What we need to know is in each one of those projects what your role was and how you fulfilled that role. You may have been part of a team and did a portion of the design, but you sort of need to have an overview of the whole project. Within that engineering knowledge, obviously, there's an expectation that you will be familiar with New Zealand legislation, preferably the design process, which is described in the BOK, being generally through the New Zealand Construction Industry Council guidelines. Also, it would pay to be familiar with the Engineering New Zealand practice notes, the SESOC practice notes, and various industry guidelines, Steel Construction New Zealand, etc. Here, a New Zealand Bridge Manual. And obviously your CPD records, ensuring that you are current. So with respect to calculations, again, we get a fairly wide range of different quality of submission. The calculations must be your own work. We're not interested in seeing a geotechnical report submitted as part of your evidence that you haven't done. It is not the assessor's job to do a numerical check on your calculations. We will pick through them and pick out the bits that we want to drill into at the interactive. The other thing about calculations, one that's really, really important, and Stewart mentioned it, we want to know how you make your decisions through your calculation process, and that would be around ensuring that your computer analysis is correct, how you do that, whether you're looking at moment diagrams, displaced shapes, or whatever. And the other bit of a bug, I guess, is submitting electronic calculations, or a whole lot of calculations done with standard spreadsheets. We want to know that you understand what that spreadsheet does. If you put rubbish in, you're going to get rubbish out. So it's pretty important that when you submit your calculations, that you understand that the inputs and the outputs and the decisions that you make through that design process are quite clear, and you can talk to them. Next part of it is managing engineering work, which is basically task management. Again, decision making is pretty crucial here. One of the questions you could be asked is why you chose a particular structural system over the others, and what were the benefits of that. The other big one that I particularly ask is around engineering risk management and the candidate's understanding of engineering risk. Most people misconstrue that for health and safety. Engineering risk is about how do you manage your risk in the design process and the production of design deliverables and construction. And that's about verification, basically. It's understanding what you've designed and what is the appropriate level of verification or peer review required in that design, and then making sure that happens. Obviously, health and safety is a big issue, and around safety and design. Sustainability is also becoming more and more prevalent, and quality of the end product, ensuring that your design deliverable or your engineering deliverable is of a suitable quality that can actually go to the next stage, i.e. construction, or allow a client to make a decision. Professional acumen, engineering code of ethics, these are sort of a bit harder to assess through the assessment process. But the communication side of it is pretty important. We want to know that you are able to communicate with the various project stakeholders. What we don't want to see is a huge long email string of a conversation you've had with, I'll pick geotechs because they're always good picking, with a geotechnical engineer trying to discuss some points. Trying to wind your way through an email string is probably the most mind-numbing exercise that I'll ever come across. So I'd prefer that wasn't part of it. And the really important part, again, it's in conjunction with part 1 and part 4 are the two main evidence groups for structural engineering, and that's around developing technical solutions. We really want to know your decision-making process and how you've employed engineering judgment. Those are the really key factors that we want to understand, that you actually have the understanding and the ability to make those decisions. And that's where the BOK list becomes pretty useful in terms of giving you guidelines in terms of what we're expecting to see. The interview itself is, what will happen with the interview will be that you will be asked to present 1 or 2 of your work examples. You're not asked to do anything outside what you haven't already presented in your submitted evidence. You will be asked to talk through those, and we will then probably question you on 1 or more of those work examples, or maybe even all of them, depending on how we're feeling on the day. And I think the interview is not particularly onerous. It is pretty interactive. At the end of that interview, we'll probably give you a fairly good idea of what recommendation we're going to make, and or whether you need to submit additional evidence. So and then it's the interview is not the important part in my mind. It is actually the written and submitted evidence. So again, I guess in summary, just approach it from a point of view of carrying out any other engineering project and follow through that logical process. And I think with that, I can wind up.
Thanks, John. It's always good to get a bit of insight on what's happening on the other side of the table at these things. So next we're going to hear from Amber, who's going to share her experience pulling together her CPEng application and what that process looked like after the application was submitted as well. She has 8 years of consulting experience and attained her CPEng last year. So Amber, I'll hand over to you.
Hi, I'm Amber Coulthard, structural engineer at BEKA, and I got my CPEng early last year. Since Stewart and John have talked about some of the technical content that you could be putting into your CPEng application, I'm going to focus on actually putting the application together and where some of that technical content actually goes. I found that part of the hardest part of putting together an application. If you've thought about putting in an application, you've probably been to the Engineering New Zealand website and looked at opening an application, which you go to career and click on assessments. One thing to note that I found was that the option of opening an assessment wasn't actually available to me when I was still categorised as an emerging professional member. You automatically become a full member after 5 years, but you may need to contact Engineering New Zealand just to make sure that does happen. Or you can go through the Emerging Professional Development Program if you want to become a full member sooner. Once you've opened an assessment, you'll get a page that looks something like this. The first half is pretty quick form filling, noting that your practice area description is quite important, as Stewart and John have talked about. there is a lot of good guidance for structural engineers. We're kind of used as the example because I think it's a bit easier to define what we do than some of our colleagues in different disciplines. The first thing I did when I was planning on doing CPEng was I found and talked to my referees that I wanted to make sure that they'd be happy and they thought that I was ready to apply for CPEng. And if they don't think you're ready, they might give you some advice on what gaps you might need to fill. And if they are your senior colleagues, then they might help find you work to fill those gaps. The next thing on the list is the professional development. That's your CPD records. We know these are really important, and we all know that we probably should start putting them together now. Don't wait until you apply for CPEng, because putting together 5 years or so of learnings from various seminars or readings that you've done is a lot of work. One thing to note is that you don't have to put it into the Engineering New Zealand website. You can, like I did, have an Excel spreadsheet which has all the points that the Engineering New Zealand website asks for, and submit a printout of that spreadsheet instead of inputting each one individually, because that can be quite a lot of work. The next one, self-assessment. These are essentially 500-word cover letters for the 4 different competency areas. The real guts of your assessment and where most of your work goes into is the last one, evidence. But before you can start filling out your evidence section, you need to set up your work records, basically your projects, which to do that, you need to go out of your assessment, go to work records and set up your work records for the projects that you want to do. I've done a bit of a snip of my work records, hidden away a bit of the information. I used 5 projects for my assessment. This is definitely the upper limit based on all the advice I got. I chose to do 5 projects because I had 4 new builds that I wanted to talk about. And I also had 1 DSA, so I could show that I could do assessment work. I did focus on 2 of the projects primarily and use the other 2 projects to highlight some differences in them to show a little bit more breadth. If you go into one of these work records, you have a few sections to fill out. The first one is the activity project description. And this is where you talk about the overall project and what it is. And so I copied out little bits from my design features report or something like that, basically, so the assessor knows what it is you're talking about. The next step, and here is where I actually put my complexity statements, though I think possibly they'd fit in just as well, even better in the evidence section later. And then the next section is your role description. So as Stewart and John have talked about, it's really important that you say what you did in this project using language. I did this design, or I did the construction monitoring. And then lastly, you save in your PDFs that you plan to use to refer to in this section. I had a range of structural design features reports, specific pages of calculations and drawings, some project communications and sketches that I did that I specifically talked about in my assessment, making sure not to just dump in a full set of calcs. I pulled out a section of calcs that I wanted to identify to show a process. I did use a couple projects from my previous employment. My advice would be, if you're thinking about it far enough advance, get permission to and take a few relevant work samples with you before you leave whatever job and move on to your next one. Otherwise, I did actually end up wanting a couple specific items which I didn't have, and I accessed them through the property files through council, which for Christchurch City Council was a pretty easy process because all the newer jobs are digitised. So I got a disc with everything to do with the jobs, and fortunately, because I had submitted a lot of the bits and pieces, I knew exactly where to find what I was looking for. So once you've filled out your work records, what you can actually start doing before you even start doing an assessment. So I had a few set up beforehand and so I could keep track of them over time. You go back to assessments, into evidence, and then from there you select and pull through those work records into your evidence section. You can see I've got those 5 same jobs as well as my CPD spreadsheet, because that's also evidence that you use in your discussion. And so within that work record within evidence, those 2 sections that we just talked about copy over, and then you have the section, tell us how this record supports your assessment application. That is where most of your work of your application goes, where all the bits and pieces that John and Stewart have talked about. You need to put all that into this section right here. And one thing to note is that you're going to be putting in on a project by project basis, as opposed to if you list through the competencies, you might say, I want to use this project and this project to show this. You'll need to separate them out to the separate projects. So to do this, I decided to have a plan. I put together a plan of how I was going to meet all the various performance indicators. I put together a plan, and I based this on something by Tim Armitage, meeting performance indicators, because at the time he was doing presentations. And so here's my example of my plan that I put together for the first competency, engineering knowledge. I picked one project, Langlands Hotel, which I focused most of my discussion for engineering knowledge on. And I planned out what work examples I wanted to use, and then I made some notes to myself of how these were going to meet the various performance indicators. I also did, because I wanted to show that I understood that assessment is quite different than design, I discussed my DSA in the section as well. And I also had a very small other section for another job, because I wanted to show my understandings of different New Zealand conformance pathways and alternative solution. So with this, I copied my 500-word statement into the self-assessment section, and then I had the different statements for the different jobs, which combined the 4 different competency areas, and copied those into the various evidence sections. One thing to note, I didn't use all 5 projects for all 4 competencies. I really focused on making sure I could do a good talk about an individual project and support that with some other ones. So once I'd had all that in, once I had that all typed up in Word, copied it into the online Engineering New Zealand website. I made sure I proofread it. I gave it to a colleague to look over and give me some feedback, and then I hit submit. So after I submitted, there was a pretty quick response where they checked through. There was an initial, is everything there process. Then I had to wait about 6 months for a panel to be found. Imagine our assessors are still fairly overwhelmed, so expect a little bit of a wait. I had an online meeting with my practice area assessor and the main assessor, where we discussed my projects, and I was asked some questions about my projects beyond what I put in my assessment. For example, my practice area assessor asked me about some fire related aspects of one of my projects. And then I made some updates. My main assessor identified that my complexity statements were a little bit too generic. I'd followed the advice of using the complexity definitions a little bit too closely. So I just updated each of them to make them unique to each project. Fortunately, my assessors could identify that all the projects that I put in were complex, and so that was just a pretty quick process. And then the assessors sent that through to the board, and within about a month later, I got my formal approval. So I guess it does take time. I took about 6 months to get the time and motivation to put it together, another 6 or so months for the process to be complete. So if you want CPEng a year from now, you should probably start thinking about it and putting it together. Hopefully, I've given you some helpful hints to get started. I'll now pass back to Laura.
Thanks, Amber. That was really awesome to hear about your experience, and congratulations. Finally, we're going to get a bit of a peek behind the curtains and learn about the future of CPEng. So to talk about that, we have CPEng board member Paul Campbell and SESOC President Michelle Grant.
Tēnā koutou. Thanks, Laura. So as Laura said, I'm Paul Campbell. I'm a CPEng board member, and I stood for the board because I've been on a bit of a crusade around CPEng since I was SESOC president sort of 8-ish years ago. I'm really passionate about engineering as a profession, and I am proud to be a structural engineer. So the situation as it stands right now, the government has basically said, and I agree, and so does Engineering New Zealand, that the current CPEng system isn't working for the profession and it isn't working for society. Please let me know if the background noise is being distracting. Sorry, I got kicked out of a meeting room. So the CPEng system that we've currently got is covered by 2 acts of law. There's the CPEng Act and the CPEng regulations. Now, as a CPEng board member, we cannot make wholesale changes to CPEng without changing the law. So we've got, if you like, some rules that we've got to work to. What we can do and what we are going to do is we're going to effectively, within our current rules, try and tighten up. And what we are doing, and hopefully successfully, Engineering New Zealand, supported by the board and SESOC, we're looking at strengthening your understanding of what the current rules are. We're then looking to apply the current rules in a much more transparent and consistent way. So things like the BOKS are really important. So what does this mean for you as a first-time applicant? Expect to see more guidance coming out this year on what CPD looks like and what good CPD looks like. Okay. We're going to give guidance. You know, I'm not interested in seeing a structural engineer saying that they went to night school to learn how to type. You know, we want proper CPD that's related to your job. And sort of a message, I totally agree with what John said. If you treat your application as your most important client and like a really, really important project, and you have pride and all that in it, you will want to impress with your CPD stuff. So we're really looking for that. Expect to clearly demonstrate that you have met the achievement. The assessors, they're not private investigators. It is not their job to hunt out, to find out whether you have achieved the required standard or not. If you don't prove it beyond doubt, expect to get a rough interview and possibly not a good outcome. So the best advice I can give you, and Amber said it, John said it, get yourself a really good mentor, get your evidence critiqued, and make sure it's the best that it can be from your point of view. Expect some documentation coming out on the type of evidence to submit. You know, the BOKS is really great. We want to see projects and we want to see what you did on the project that demonstrates it. Expect, and this is a little bit of a funny one, but expect more guidance and expect to be extremely thoughtful about who you use as a referee. You know, sometimes you have to use people in your firm. One of the best referees you could use would be a BCA officer or someone that regularly peer reviews your work that isn't associated with your company that you work for, you know, and someone with mana. So be really thoughtful about who your referee is. And sometimes you're not ready. So take your referees and take your mentor's advice and fill those gaps. Last word for me before I hand over to Michelle. The CPEng board is looking for opportunities to improve. Now, we've got an open door policy. Please come to us if you see anything that is a no-brainer and say, for goodness sake, why aren't you doing this? We'd love to hear your thoughts on improving the system. And I'll hand over to Michelle now, who's going to talk about occupational regulation, which is CPEng 2.0.
Thanks, Paul. Thanks for that. Just by way of introduction, so I'm Michelle Brown, I'm the current SESOC president. And I just want to say, look, us structural engineers, we've had a lot of media focusing on us in the recent past. Since I've been SESOC president, I've been lucky enough, I suppose, to field a number of inquiries, and it's honest to say that unfortunately a lot of this has been negative. But if any of you heard the recent interview with Phil Pennington, one thing that I made clear was that SESOC is welcoming some changes, that we want change, and we really believe that it's something for us structural engineers all to look forward to. Anyone who knows me here would know that I always try and find some positive in situations, and I have to say there is a positive in the press and the issues that we've been hearing about, and that is that it's been a really effective catalyst for change. So for today, I just wanted to focus on quickly talk about two of the changes that are going to be making a big difference in how structural engineers operate. The first, like Paul was just talking about, and I won't talk about it too much, is the work that's happening within Engineering New Zealand and SESOC around providing some more transparent guidance for people applying for CPEng on what's expected, to hopefully try and make it a little bit simpler for assessors, or to encourage people to address the things that need to be addressed for an assessment to progress. Paul's talked about this, and I don't want to talk about things that have already been talked about. So I just wanted to say, as some of my experience as someone who works in a small company in a regional area who trained overseas, and I don't know how many of you here today of the 300 odd participants might tick any of those boxes. It is something when you're looking at CPEng that you need to be really focused on and aware of. In terms of referees, it's more challenging for those of us in a smaller company. For myself, I redid my CPEng about 3 months ago. Took over 12 months to get through the system with the current backlog, but I had to really think and be prepared years in advance of who I was going to be asking to be my referee, because I work in a very small company and I have a co-director, so that's one referee, but there's also a commercial interest there. Who's my other referee? So I needed to make sure that I was thinking about who in the industry has mana, who's a fellow, who has a good reputation technically, who can I talk to, how can I make sure they're familiar with my work? So there's things in small companies we need to think about. As someone as well from a small company, I just really encourage you to get involved in SESOC, Engineering New Zealand, NZGS run webinars that everybody can get into, to get that CPD and to get that knowledge that is a little bit harder for those of us in smaller areas. Just as a slight CPD plug, in September and October, we have a SESOC seminar, for example, coming up, where I'll be co-presenting on a seminar of the 10 tips for the better design of low-rise structures. Practitioner-based, practitioner-focused, and it's all about the design of low-rise structures. So in terms of appropriate CPD for those of you operating in the low-rise space, hopefully I'll see some of you there, come up and say hello. So focusing on the most major change that's coming up, and that is licensing of structural engineers. This was one of the recommendations out of the Canterbury Earthquake Royal Commission to ensure that only competent people are designing high-risk things. SESOC's been lobbying for change for many years in this space. And due to many, many factors, we haven't been able to get the political will, and it's really great and so encouraging now to see that political will swing in behind us and licensing is happening. CPEng, the difference between the two, CPEng has traditionally been run as a general quality mark. And this aim doesn't quite fit with what BCA's consenting authorities need and the system needs from it. There's no legal requirement to be CPEng, and in fact, there's no bar to someone continuing to call themselves a structural engineer after poor behaviours or design. We can't stop people from practicing under the current regime. The new regime of licensing will be a two-tier system. What this means for you is that there's 2 steps that will cover us as structural engineers. First, all structural engineers will need to be registered. And the second step, those in higher risk disciplines, which is us structural, will need to be licensed in order to practice. And the details of all this are still up in the air. For registration, the first step, it's likely that most of you in this room right now would be registered under the new system, because to practice as a structural engineer, you will need to be registered. You need to have a minimum qualification, be subject to a code of ethics, and to continuing professional development requirements. For licensing, which is the second step, you'll need to meet stricter competency criteria and reapply for your license to be renewed periodically. Exactly how this works, it's very much up in the air still. But what this means is that for the very first time in New Zealand, who is able to practice or sign off on work will be legally restricted. Licensing will come with arguably greater responsibility. The penalties have been significantly increased. I don't know if many of you have read the cabinet paper, but it talks of the introduction of a criminal offence to provide professional engineering services without being registered or to practice without a licence where one is required. So it's certainly a step up in terms of both the carrot and the stick for us structural engineers. There will be consultation on how this system will work and be implemented. The legislation is sitting there hopefully soon, but all of the regulations that come out of that are still to be ironed out. And there's an opportunity for you all to provide feedback. SESOC, we'd love to hear your thoughts on licensing, and we will be going out to people at the different stages when we're asked for feedback to our members. So as SESOC's president, to finish off, I can assure you that SESOC will be doing and continue to do everything we can to enhance the reputation of engineering as a profession. SESOC wants to continue to support you as professional structural engineers. And just to say, we want structural engineers to be successful. We have a really great history, our heritage of structural engineers here in New Zealand, something that we can all be really proud of. And we look forward to that continuing into the future. So interesting times ahead for us all. Thanks, guys.
Thanks, Michelle and Paul. Really interesting to hear about how that's progressing. We do have some time for questions now, so I'm just going to pick through some of them at the moment. The first one I have here is from Nitesh. Can the experience or project work from overseas be included in your portfolio for chartership? Michelle, you might be able to answer that one.
I was going to say, yeah, so I trained in Australia, and when my initial chartership application, yes, I did use some of the experience on the much larger projects I was involved in Australia. However, I had to make sure that I had a really strong focus on seismic, particularly CPD, appropriate CPD in New Zealand, not just on the job reading, attending hours and hours of training courses, conferences. I had to very clearly demonstrate that I was familiar with the consenting process in New Zealand, the system within which we operate and how that all works. So yes, you can use some of your overseas experience. If it is non-seismic, just be very mindful of that. But you do need to make sure that you clearly demonstrate you understand the New Zealand environment.
Thanks. There's a couple of questions around what Stewart was talking on at the start in the box. Can you please advise, if I've only designed temporary works, what specific requirements in the CPEng process for that?
Yep, I'll answer that. Good question.
Thanks.
If you've only designed temporary works, you're likely to be, I'm guessing, and you're in a design office, it probably won't meet the criteria for CPEng. However, if you are on a site and you're a site engineer and you're applying for a field as a construction engineer or project management, and that's a part, one of your tools, then it's likely that you, if you can demonstrate the complexity of your decision making as a project engineer or a construction engineer, then it is likely you'd get through.
Thanks, and I think that answers another question from Michael, which was, he mentioned that the box is primarily written by and extended to design-focused consulting engineers, and any advice for aspiring CPEng candidates in a construction or contracting role who don't carry out design work but carry out construction projects.
Okay, I don't agree with that. I think many of the box do apply. You still need to understand load paths, safety in design, safety in on site. And if you don't understand temporary propping and temporary loads, then you won't get through CPEng. But most construction engineers that I've come across recently that have applied have adequately provided suitable evidence to get them through, but they are demonstrating those, how they've made decisions and the complexity of those decisions in addition to propping.
A question here perhaps for John. Is it better to be as detailed as possible in the application, or would it be preferred to be more concise?
Bit of both. Don't necessarily want to read screeds and screeds of information, hence being concise, but you really need to show the processes and explain your knowledge base, how you've gone through that those design processes or construction monitoring processes, etc. So yeah, it's a bit of both. It's a bit of a balance, and as we've said before, make sure you get maybe some mentoring, and definitely get your submission reviewed by someone that's been through the process.
Thanks. Perhaps another one for you, Michelle. I'm working in a company that do 90% work for residential housing. Due to the nature of this, the projects are mostly not complex at all and don't need sophisticated analysis. I can see BOKS as most likely applicable for large commercial buildings or DSAs, which I don't have the experience on. Can I still proceed with a CPEng application?
Oh, as someone who works in low-rise and residential space, I feel a little bit personally attacked by that one. I would have to say that residential can be very complex. I mean, I work on residential and commercial, and residential projects, please don't downplay the complexity that you have in a residential project. So yes, the BOKS is still applicable. I've unfortunately seen some really poor designs in the residential space and had to fix some poor designs that have failed when load paths haven't been followed properly. So speaking from the other end, yes, there's a lot in residential that needs to be considered. You still need to show an understanding of load paths. You still need to understand the concept of ductility. Deflection compatibility is probably more important in residential than commercial. Interaction with the architectural requirements, usually more complex, I find, in residential than commercial. Architects have very strong opinions about things, as you would all know. Nuanced in the geotech space, you have all the materials. Usually you're working with steel frames, steel components, their interaction with timber and concrete with your foundations. You have to know very clearly where 3604 stops and where SED starts. So I would argue that there's quite a lot of complexity in the residential space. So yes, I think it's appropriate still. I'm not sure if I've answered the question, but yes, it's appropriate still. The BOKS is appropriate still. And yeah.
Thanks, Michelle. There's quite a few questions. Yes, the recording of this webinar is going to be made available at the end. Please do be patient. It might take a little bit of time to come out. And similarly, the BOKS are freely available on the SESOC website as well, but we'll send a link with that when we put the recording out. Sorry, just scrolling through now. Perhaps a question around the future of CPEng. Wouldn't a written exam be a better tool to demonstrate competency for all those listed criteria instead of a work example based assessment?
Do you want to take that one, Paul, or shall I talk about where that might fit? So with licensing, for example, which is coming in the very nearest future, it's possible that we may end up with a written exam component. Like I was saying, how we actually apply licensing is so unknown still. It's still up in the air. Within the current system, it's tricky because we fit within the rules. And Paul, shall I leave you to make any comment on that?
Yeah, look, there's a difference between an examination and an examining the evidence. The main thing is you demonstrate your competence, and you can do that in a number of ways. And under the current system, if there is some doubt as to the evidence you've submitted, you will get a written question, and which is basically an exam. So those tools are available. But you know, in life, I mean, we practice in an open book environment, not an exams condition. So, you know, we hand in our designs to the BCAs, to our clients. What we're asking you is effectively to do a job, and your client is yourself.
Just to, so everyone's not, when I first went for CPEng, I had an exam question that was asked of me to clearly demonstrate that I understood capacity design coming from overseas, which I thought was a really good question and really fair.
Just further to that, without letting people know exactly how old I am, I went through the original engineering registration process. I had to say it in the early 90s, where you had to submit pretty much the same evidence that you submit now. You went through the most terrifying interview that I've ever had, and I had to sit, everyone has to sit a 3-hour exam or write an essay in the afternoon. So it was a full day event, slightly less onerous than the iStruck-E English system, but yeah, as Paul said, if there is any doubt in any of your practice areas or submitted evidence, you will be getting a question.
Thanks.
I think I should just say that moving forward, this could change. We have a different system in New Zealand. We're the only people who do a review every 6 years. So it's not as if you sit an exam like iStruct-D and then that's it for life. Nothing else happens except demonstrating CPD through your career. And Australia, same, you demonstrate annual CPD. It might be every 3 years there, I can't remember, but you have to show that you've fulfilled so many hours in different categories for CPD. And this is something that the board that Paul's on will be looking at. And I'll say, don't exclude the possibility of tests being adopted or exams at some time in the future. But at this stage, it's not required unless the assessor sees it being necessary.
We've got a question here. For submitting a CPEng application, what do the CPD requirements look like when someone has taken a year on maternity leave? Do we still need 40 hours over that year?
I could probably take this one, having been in that situation myself twice. During that year, no, I don't think I could have done CPD because I wasn't sleeping. No, but I think the important thing when you're coming back from a career break, whether you've taken a year OE or a year off to not sleep on maternity leave, is just making sure that when you do come back, you get up to speed on whatever you may have missed in that year that you're off. So it's just making that extra effort when you come back, I suppose, to make sure that you're getting back into it and seeing, what might have come out or changed in that time frame.
Engineers specialising in horizontal structures, i.e. bridges, assessed any differently to those doing vertical structures? I can see some shaking heads.
I was going to let Stewart or John jump in.
I've jumped in. No, the same principles apply. The BOKS apply. You've got load paths, you've got forces applied to the structure, you've got interaction with soils and so on. And nothing's different.
Just on top of that, your practice area assessor will be familiar with civil structures as opposed to vertical structures. So there will generally, Engineering New Zealand tries to pair the practice area assessor up with the practice area description.
And it's probably fair to say that there's a lot more reliance on the Wakakatahi bridge manual and things like that than what you would have vertical structures. But yeah, it's the same load paths, same structural concepts.
And further than that, I saw another question which was, oh, hey, my assessor is an electrical engineer. Yes, that does happen. Many of the lead assessors, these are the ones employed by Engineering New Zealand to administrate your application and provide the report to the Competency Assessment Board. They could be any field whatsoever. They're about process, but assigned to each project or to each candidate, that'll, in addition to the lead assessor, be a practice area assessor who will be in the discipline of structural engineering and hopefully aligned with the sort of work that you do as a candidate.
Thanks. And we've just gone 10 past, so I think we'll wrap the questions up there. Michelle and Paul have both mentioned that to reach out if you have any interest in or any ideas in contributing there. But otherwise, I just want to say thanks again to all of our presenters who've provided some pretty valuable insight to that CPEng process. And thanks to all of you for joining us for this webinar. Thanks.